Yes, good afternoon, all. And as far as our topic is concerned, in the case of this mechatronics, yesterday have been looked regarding this amplifiers, inverting and non-inverting amplifiers, which are widely utilized in the VLSA circuits for decreasing the overall lengthiest or dimensions of the ancient circuits, circuit boards, and we'll be today discussing regarding this differential amplifiers, which is an additional parameters involvement with respect to the differential characterizations in the case of these amplifiers. So nominally, we'll be recalling the non-inverting and inverting amplifiers as a glance. So non-inverting, which will be connected towards the positive input terminal and due to analyze the output, and the voltage output leads towards the voltage input of 1 plus R2 by R1, as you have been discussed in detail in the previous class. Moving on to the inverting amplifiers, which will be connected to a negative terminal as per the diagrammatically we'll be seeing here. This is a negative terminal. This is considered as an inverting amplifier. And when this signature has been changed towards the positive, it will be scheduled as an the non-inverting amplifier. So in the case of this inverting amplifier, output voltage will be obtained based upon the negative voltage of reference resistor to the input resistance. Upon integration, the capacitor, the indulgement of or incorporation of this RL or RC circuit, there is a resistance and capacitor implementation. The magnitude of output will be determined by the length of the time or voltage which is present at the input that is connected to the inverting terminal towards this resistance and thus the capacitor. At the output terminal, and hence the positive terminal is connected towards the ground, and at the output terminal, if the current that has been increased rather than the input power supply, then it will be stored in the form of this capacitor, and this input can be cut off to a maximum extent as this resistor is almost connected with respect to the capacitor. So in need to activate this RC circuit, hence it is called as a closed loop amp as it has been specified here. It integrates the inverted input signal over the overall time period basis. And hence this RC circuit plays a major important role for the entire charge that is being stored in the capacitor and will be utilized when it is necessary to commence the statistics of operation instead of the entire system getting into an halting position. The stored energy in the capacitor will be reinitiates the input resistor in due to operate the amplifier, and corresponding terminations or process will be getting taken place. As you have been seen in yesterday's class, upon both this integration or integrating of this operational amplifier, how the output is being obtained in the case of this both inverting and non-inverting. And when the capacitor is fully charged, then the entire circuit will be acting as an open circuit with infinite resistance and leads to an output voltage to a saturation level that is most probably 80% of the situation, that is power supply voltage. And upon this integrating, we'll be obtaining the output as a sawtooth signal which hires from the 0 to maximum of minus 15 volts. as per the input given in the form of an square wave representation. This is the considerations we have been seen so far. And moving on to the differential amplifier, the connectivities are as follows: that at the point of voltage 1, there's a non-inverting terminal, is a positive terminal, which is an input given to the resistance 1 and the resistance 2, which is connected to the ground. The difference of this both differential identifies the input resistance between the resistor 1 and the resistor 2. Simultaneously, the ground terminal V2 voltage 2 will be identified as per this resistance 3 and resistance 4, which is connected towards the input terminal of resistance 3 towards the inverting terminal. And next, the output voltage which has been obtained is connected, it is an interconnected with respect to R3 and R3 by the R4. So what is the difference is that the voltage is being developed between these resistors at the inverting terminal and as well as the non-inverting terminal. And what is the difference output, or output is being exceeding in the gain or else the loss need to be identified. So as per the given circuit diagram in the operational amplifier, what are the kind of operations or differential statistics? Here, different types of resistances are being produced based upon the given input voltage, and both the terminals are being in switch on activities. How the voltages are being developed will be looking after now. When considered in the towards the non-inverting voltage terminal, there is a V positive or V plus is equal to V1 of R2 by R1 plus R2. Because of R2, there is an output or maximum voltage or resistance that is being produced as the input voltage implies towards the or passes to the R1 resistor, and which the incremental voltage developed or resistance based upon the incremental of resistance will be lead towards the R2 resistor. And the junction point of this R1 and R2 generates or having the much more resistance, which has more EMF developed will be much more incremental, and upon both merging of these resistances will be forwarded to the amplifier operation amplifier as an input, and simultaneously towards the output, what is the gain that has been obtained based upon the given input as per the non-inverting amplifier terminal given. So V plus into G plus, or based upon the given voltage input as per the variation occurs in between the two different resistances, and the gain that has been obtained after the performance criteria. So what is the performance criteria that is being taken place with respect to the input of R1 and R2 resistances based upon the given voltage input, and towards what are the differences that are being obtained in the case of this R3 and R4, and what is the output voltage as V2 is being obtained. Here, the main purpose, that is a differential amplifier, is to produce an output proportional to the differential of input voltages, nothing but V plus as given, and what is the V2 that is being obtained in the output strategy. So here the R4 resistance is directly connected from the output resistance, and here R3 is interlinked between this output resistor towards the inverting terminal, which the operational process need to be progressed, and hence it has been a common connector to the R3 and R4, to which it is having a ground connection. So hence this ground connection distance 0 ohms, and this positive terminal generates as an output voltage, and EMF will be traced out between the maximum voltage developed in the resistance 4 leads to the incorporation or generation of the incremental in resistance of R3. So hence, a common combination of this R3 plus R4 and the current that is being fed out in the junction point with respect to the voltage 2 factor in the resistor of R3. There is a proportional basis of output proportional basis. And hence, we have the formulation that V output is equal to voltage given as a plus in the non-inverting terminal plus G plus. There is an V1 of R2 by R1 plus R2 into R3 plus R4 by R3. And hence, what is the, as per the input we have been verified, and what will be the output at different terminals. So upon simplification factor, by taking this R2 as a common here, the voltage output 2 is V2 of minus R4 by R, and vice versa of voltage 1 output V1 of R2 by R1 plus R2, and minus the generated voltage of output terminal 2. And so on, and final will be having this the differential voltage when compared with respect to both voltages input 1 and 2, which is multiplied by the resistances 4 and 3, and scales the following difference, leads to the following difference. There's an difference is when compared to the both terminals, as the input the resistance generates based upon the input the operational process leads to generate, and the corresponding output has been obtained. Coming to the point of this summing amplifier, almost all the resistances that are being given with respect to the voltage as an input to each and every resistor as a triggering element, which is interlinked at an input resistance towards the inverting terminal, and a feedback resistance which has been connected from the output towards the common connector to the reference resistance or feedback resistance. And hence voltage passing VCC, nothing but processing voltage, which is taking place at an operational amplifier, and the resistance B, which is connected towards the reference, how much voltage should be obtained, and will be, it has been connected towards the non-inverting terminal, and corresponding output generates. What is the corresponding output? Generates. So summation here accumulates or almost all merges the resistances based upon the given input voltage 1, input voltage 2, input voltage 3 towards the corresponding resistances, that is Rg1, Rg2, Rg3, which is commonly connected to an terminal of inverting, leads to an output voltage of minus B input 1 of reference resistance by resistance 1, simultaneously input voltage 2 into feedback resistance by resistance 2, input voltage 3 and proportionality of reference voltage by the reference resistance by the resistance 3, and so on. If the voltage input 4 with respect to the resistance 4 has been connected in common with respect to the inverting terminal, it is increases furtherly. It's all of plus, instead of commencing the operational strategy, the difference voltage is connected with respect to a resistance of B. So here the reference voltage plays a major role, that there is an interlinkage factor with respect to the output resistances. And this output resistances, which is commonly connected to the three different input resistances. There is an V reference of 1 plus feedback resistance by Rg1, 2, and 3, so on, multiplication factor. And here the summing amplifier does exactly the name suggests, by adding the voltages given at an input and produces a corresponding output voltage, which is the sum of input voltages scaled by the feedback resistances. So as the input terminals which has been connected processes the ideal strategies, generates the corresponding output by a scaling factor based upon the given input resistances generation with respect to the voltage factors. As it has been a graph shown in the graph, it has been plotted of output voltage to the input voltages of three voltages. And for example, considering of this voltage 1 as in 1 volt and input voltage 2 minus 1.5 and input voltage 3 5 volts. So here it has been specified clearly that minus strategy and positive strategy. Corresponding output has been scaled off 5 volts as in frequency range of a maximum, and here the reference characterized towards the 0.625 volts. This is the factorial representations, that is having the scaling factor upon the given input reference voltages to the resistances. Moving on to the, coming back to the summation condition or differential amplifier strategy, that the variations are being taking place in between a resistor, one resistor towards the other resistor, compares the terminal basis upon the processing, generates the output which is having a common interlinkaged connectors. This differential leads to formation of both the factors, that is an summing and next even subtracting basis. So here subtracting has been indicated with respect to the differential amplifier. Here subtracting incorporates with a term that as a differential amplifier. So here an addition of this voltage input 1, voltage at input resistance 1, input resistance 2, input resistance 3. So for our convenience, as you have been considered the summation of these three with the sign factors leads to 4.5. That indicates here a maximum voltage generates as the input voltage is 3. That is a voltage plotting of graph, output voltage versus input voltages leads to a 3 as a maximum. And where we will be utilizing these differential amplifiers and summation or summing amplifiers. Here we have to notice an example that we'll be utilizing in our daily basis, and most probably these or utilized in our filters. Nothing but increasing of frequency levels or decreasing of frequency levels. Commencing with a small example, as the amplifier have been connected to from the controller. As the resistance we are increasing, nothing but increasing of the volume, increases the frequency or bandwidth of the output at the output, leads to incrementing in the volume. It's increasing in the volume, as it leads to when the general nominal output voltage has been generated. If it is an having decreasing in the strategy as per the demand, will be limiting the output resistance by commencing some capacitor, by utilizing a capacitor, by it will decrease the voltage generating at an output, and the decreased content will be stored, or decreased resistance or voltage will be stored in the capacitor, hence leads to an incrementing of the volume or decrementing of the volume based upon the resistance or voltages or differences of this voltages generated at the corresponding resistances, output resistances based upon the given input conditions. So hence this place, so summation leads to incrementing of the voltage factor and increases the sound frequency at the output in the amplifier. Simultaneously, differentiating leads to decrease or increase. Both the activities can be commonly performed in the similar strategy and most probably utilized in the filters. There's an low pass filter, high pass filter, band pass filter. As these filters has been characterized or classified into three different types, and even furtherly more as per the circuit design. Low pass filter mainly considered into an conditions, it is a low pass filter, high pass filter, band pass filter, and cascade. And even it is utilized in the strain gauge also as well. So strain gauge. So we all aware of this strain gauge that based upon the given loading conditions, corresponding output in the form of strain values will be measured and will be clearly identified with respect to mechanical objects, that the strain will be occurred with respect to changing in its dimensional accuracies. So here that will be indicated in the form of an electrical signals, as the resistances up to the optimum limit will be given, and furthermore based upon the given input loading conditions, if there is any fluctuations occurring or else input very furtherly varying, then corresponding resistance will leads to give the strain value on that particular gauge, as cleared, as specified clearly here. The difference in the voltages, the commonly conducting voltages, what are the voltages, and a negative voltages. This, upon the implication of the forces or pressure or the load conditions, what are the changes that are being taking place at the opposite levels. There is an R1, R2, and hence balanced condition is 1 and unbalanced condition is 1. So in the case of this balanced condition, there are no any strains occurred, as it has been displayed in the case of a first diagram, pictorial representation. With respect to the second pictorial representation, these unbalanced conditions, because the load is being very much high in the case of this second or end of this particular cantilever beam. One end is fixedly supported and another one it is an open conditions. And at this particular stage, this differential amplifiers plays an important role indeed to identify the strain values or strain levels in between the one particular segment to another particular segment within the objects. There's a chronological connections in of this strain gauge indeed to measure the variations occurred due to the implication of loading conditions. And even it lays in PID controllers. So here PID controllers. PID specifies for proportional integrated differential controller. Proportional integrated differential controller. Even we are having this particular experiment also in our laboratory process, and especially this PID controller is existing with respect to in the EEE department. The major goal is to have the set to voltage at the output. So how much voltage that we have been set, then we are considering two different systems. It is an open loop control system and closed loop control system. As per the desired conditions at the input level, we need to obtain the corresponding output. If there is a does not obtain, doesn't out the output terminal, it doesn't obtain the certain conditions, simultaneously this feedback sensor give the signal to a reference channel. This reference channel further verifies the error that has been lagged with, or else any additional voltage has been developed at that output terminal. It has to be limited. So it is proportional in the sense incrementing also. So that is increasing. If any shortage that has been occurred at an output, for example, the input set voltage is 20 volts need to be obtained at an output. But upon the processing, if in the from the output operational amplifier we have got 19.5 volts, then the feedback will be given by this particular feedback sensor to the error verifier, or else the reference channel. This reference channel will increases the gives a signal to the PID controller, and this controller will highlight the summation. There is an incremental amplifier, and then the resistance will increase. And based upon that, that point 0.5 volts will be compensated, and the corresponding output will be continuously provided to the voltage. Because if at all that 20 volts haven't provided to that particular uh, machinery, it can't progress the corresponding output that need to be performed in a prescribed operation of the machine. And hence, if our main motto is getting 20 volts of power supply, so instead of getting 20 volts, if there is any incrementing of voltage that has been developed at the output, that is 25 volts, and have to be decreased that 5 volts by this differentiating amplifier. So this differentiating will calculate the overall output signals, and based upon that 5 volts will be limited here, and that limiting voltage will be stored in the form of a capacitor and will be compensated whenever they have been getting in a shortage characterizations. So this is the strategy of a proportional integrated differential control. So at the end of our output, indeed to balance the required conditions, it will be increasing based upon the closed loop circuit which has been connected from the output towards this the reference channel, and the error will be compensated and start continuously or strategically it will be passing on or giving supply towards the 20 volts. Or else if there is any shortage, any excess that is leads to generate in the process, simultaneously it limits that particular excess and continuously will pass the 20 volts by limiting. So this is the strategy of PID controller, and hence the circuit where we utilize this PID controller in the application point of view. for signal conditioning, which allows you to introduce the time delay, which could account for things like inertia. So these are some of the applications where this amplifiers has been utilized indeed to balance or increase or decrease the voltage strategies. Thank you. By this, we'll be closing this session, and we'll be meeting in the another session with respect to an voice levels or nothing but this operational amplifiers with respect to the reducing noise levels.